Hey guys, welcome back. So in this video, I'm going to talk about hypothesis testing, most word in statistical methods. So I'll try to break down in layman language and as well as the technical terms as usual. So if you haven't watched my previous videos, you can go to my channel. And if you want any further videos, please comment down below so that I'll make more content. So coming to this topic, which is called hypothesis testing. So what is hypothesis testing? So in general, in the world of data science, so we always have something called as data set, right? So we always try to make some inferences. We try to learn from the data. So the thing is, the data is never enough. Whenever you try to create a machine learning model and do some stuff, data is gonna come up, it's gonna pile up, right? So it's never enough. So that's the reason there is something called sampling in the world of data. Okay, for instance, let's say there's a population of 100 people, and you make a sample out of them. Like for instance, you collect like 10 people out of them, 10 people, and the main concept of hypothesis testing is like, for instance, let's say you wanna calculate average income of these people. Okay, so you can't, in general, like population is like 1 billion people, right now. I'm not sure with the numbers, but it's quite huge. That's all I know. So you can't go to the every person and get the statistics, and even if you get them, um, it takes a lot of processing power to do that. So instead of that, in the world of data, what we do is like we take a small sample out of it and calculate the average, whatever you want. For instance, the average income is like 10 lakh dollars per annum, and you want to see whether this 10 lakh might be the case for population or not. For instance, like you have the data of like previous thing. For instance, let's say you have 2000, year of 2000, you have the average income as 50 lakhs. Oh, sorry, the average income of 5 lakh dollars. Okay, now in the year of 2024, okay, sorry guys, happy new year. In 2024, the average income of this sample is 10 lakh dollar. You want to see the comparison, like whether this 5 lakh still remains the same or not. So, it's obvious that it might increase. For instance, let's say like average weight. Take a different example. Average weight of people in back in 2000. So more number of people are getting died, and more number of people are getting add on, right? So after in 2024, you want to see whether the statistic remains the same or not. So that's the whole concept of the statistical learning, the whole concept of uh, hypothesis testing. So in this hypothesis testing, there are four different ways in which you can check whether the thing is right or wrong. So that is Z test, T test, chi-square test, ANOVA test. In this video, I would be talking about Z test and T test. Okay. So before going anywhere, let's talk. There are two terms that we need to know. One is like hypothesis, null, and the other one is like alternative hypothesis. Okay, so these are the two terminology that we need to know. What is null hypothesis? For instance, let's say we take an example of um, the average weight the population the population is 100 kg. Okay, now we got a new sample of 30 student of, let's say, 40 people. and we got the average weight as 130 kg. So we have a contradictory statement here. One says 100 kg, other says 130 kg. Okay, so which one you want to go with? So you want to see, this is what null hypothesis says. The average weight remains 100 kg. Alternate hypothesis says average weight of population is 100 kg. Null hypothesis says the average weight of population is not equal to 100 kg based on sample average that we got 130 kg. So we are saying that it might not be 100 kg. So let's see how it goes. So these are the two terminology that we need to know. Null hypothesis in the sense like the current information that we have, and the thing which we want to prove. So it says like average weight is 130 kg, right? So we want to prove that it is right or wrong. That is called alternate hypothesis. So for this testing, we have two different methods, z-test and t-test. Chi-square test is used for categorical data, and ANOVA test is for a different purpose. But in this video, I'll be covering about z-test and t-test. Both of them talks about the average of the whatever the population or sample that we want to talk about. If the concept is average, then we go with the z-test and t-test. Okay. Uh, okay. Let's start with this example. So first things first, I would be talking about z-test. So our information as per the previous one and we got is average population sample. Population mean is 100. Okay, let's say standard deviation is 5, not even 5, let's take 2. Okay, the sample which we got here, we are getting 150 kg for suppose kg. Okay, and number of samples are 35, and the further steps I'll also be explaining when to use z-test, when to use the t-test. Once I will lay some ground between all these terms. Okay, now we need to see here what you are trying to calculate is, just try to concentrate on this part, because like I did a lot of research for this. I didn't find any proper content, so this content will be very helpful for you. So here's the thing, based on the population, it says average is 100 kgs, right? So you want to see 150 kgs, whether if it is feasible or not. There is another concept called confidence interval of 95%. So here's the thing, okay? So it means most of the 95% of the data, 95%, you can strictly say it says in 95% of the time you will get average between these 2 points. Okay, so that's what it says. Means like let's suppose this is the distribution. Okay, and the whole area is 100%. 95% of the data lies in this in this period. Okay, so that's what it says. Only 5% of the data lies here. Okay, so that's what we're trying to say. In the sense, like if our mean lies somewhere here, and new mean, if the the new mean goes over these two boundaries, then we can say the null hypothesis is wrong. Okay, so that's what we are trying to prove. Our goal is to find these 2 points and check whether our weight belongs to this area or this area or this area. So if it is in this area, then we are in good. If it belongs to this area, it means it is bad. Means like we will be rejecting that. Okay. So now, how to find these two values? So that's where Z tests come into play. So Z gives us a new scale. So it says here my Z value is 0, and it will give you two, like two values, plus A and minus A. So you will be calculating A value. It means like Z value. This is Z, sorry, plus Z and minus Z using a table and a formula. I'll be telling you what's the formula. So uh, as I said, 95% of the data lies in between these, right? 95% of the data lies here. So what would be the area in the sense like what would be the area all the way from here to here? So the area would be like as I said, this 5% lies here, right? 2.5%, 2.5%, both of them together says 5%. So what is the area of all this part? Okay, so the area would be 95 plus 2.5, that is 97.5 percentage of data li lies in this left side of it. So there is something called Z table. I'll just show you. Okay, so this is the Z table that I was talking about. So as I was saying, 97.5% data, right? It means like 0.975. Okay, just keep it in that mind. And it is like right side. Okay, this is positive. So in there is something called Z table. There will be like it says what Z table says is it gives you the value based on the area covered. It gives you the value of this based on the area covered. So there is something called positive area and negative area. If you calculate positive, then it's the same vice versa. If it is plus 1, this could be minus 1. So I would highly suggest you to just consider one side and you'll be good to go for the second side. So now 0.975, sorry, I wrote it wrong, 0.975, okay. So just find the value where it's 0.975. This is a negative one, right? We'll go to the positive table. 0.979797. Oh, 0.971 right there. So it says 1.9, 1.96. So how did I see 1 point? Oh, 1.976. 1.976. Oh, it says 1.976. Okay. So 0.975 is the 975 is here. So Z value would be 1.96. Sorry guys, there is been a little bit disturbance. uh, 1.96, so z value will be plus 1.96 over here, and other one is z is equal to minus 1.96. Okay, so all you need to know is our mean value 150 kg. What is the z value of this? Now we'll get into the formula. Minus mu by standard deviation by root n. So that's the formula that you guys need to remember. So we'll be calculating z value. This is the sample mean and population mean and standard deviation of population, and it says number of points in the sample. Okay, so without any further ado, we will go it in faster way. And as I was saying, standard deviation is 2 divided by number of sample root 35. So value is 50 divided by 2 into root 35. Suppose root 35 would be 6, or we can consider 5.8. Uh, I'm just taking a rough value. 25 into 5.8, that would be around, just a second, let me put it in the calculator. 25 into 5.8, so that's 145 guys. Oh my god, let me cross check whether if I did it everything right or wrong. Okay, it says our z value is 145, so our z value is 1.96. It means like our 150 lies somewhere here. It means like it is too far away. 1.96 and 150, it's too far away. It means like we can clearly say that if our z value zr is greater than z positive, or zr less than z minus, then we can reject the null hypothesis. Can reject the null hypothesis. So hence our alternative hypothesis mu 100 is equal to wrong. It means null hypothesis is rejected. Rejected. An alternative hypothesis is proved. Is proved. So that's about z-test. And similarly, p-test, I mean like t-test. T-test is nothing but whenever you have the sample. Sorry guys, like this is something a condition I just forgot to mention. If the sample size is like more than 30, then you can consider z-test, or else like you need to consider t-test. Okay, and also you need to know the population standard deviation, which is very important. The two main constraints are population standard deviation you need to know population standard deviation. And second thing is what I was saying, and sample size should be greater than 30. So these two constraints should be met, or else like can't use z-test. So that's where t-test comes into picture. T-test. So in most of the real world situation, you'll you don't know the population, in the sense like you never get to know about the whole data set. So you don't know the population standard deviation. So you will take the sample standard deviation into picture. So in the same way, t-test formula would be x bar minus population mean by square root of, oh sorry, by number of samples. The same as the previous one, but here you will take here you will consider sample standard deviation into, whereas there you will be taking population standard deviation. Okay, so this the same way as the before one, like you'll be calculating the t-value, and yeah, there's a different process, different instead of z table you have considered uh, z table and t table will be two different things. T table, let's see, t table. You can find this kind of t table. So most of the time will be having two tails or one tail. Two tail is nothing but whenever the hypothesis, whenever you have the mean of population and the sample population is either above or minimum. So if the problem statement says it is greater than population mean, then you consider one tail test. Means like only this one comes into the picture, right? So you won't be considering this part. So if no vice versa, if it is less than population mean, then we'll be considering this. If someone says it's not equal to 100, as I was talking before, the population mean is not equal to 100. That's what I am trying to say. So then it is called two-tail test. You will consider two of them, both of them in the picture. So if I say mu is greater than 100, then I'll consider only this. So all the uh, confidence interval 95% means like all this part comes into picture, and whole this is like 5%. This 5% is called p-value. Okay, so I'll just tell you how to use how to calculate. For instance, let's say, and there's something called a degree of freedom too. Degree of freedom. Degree of freedom is nothing but number of samples minus one. For instance, let's say you have four positions. I mean like four positions to fill four guys. So you'll have first guy will have four options to choose. Third guy will have three options to choose because like one will be occupied. Second guy will have two, and the last guy will have only one. In a sense, like he has no freedom to choose. So always the last guy remains without no freedom. So that is called degree of freedom. So it is always n minus one. How many options do you have? Okay. So coming to back to the table. For instance, let's say R sample just has 15. Okay, I'll just explain you with an example. For example, our sample has 12, okay? Uh, in the sense like 13 samples, n is equal to 13 in our case, then degree of freedom is equal to 12, which is this, okay? And as I was saying, your confidence interval might be 95%, which says the p-value is 0.5. So your t-value is 2.179. That's what it says. That's how you do the thing. Okay. So t-value is 2.179. Same thing, like you'll calculate the value of, put the values inside, you'll get t-value. If it is greater than this point, then you'll reject it. If it is less than this, in the sense like if it is two-tailed test, it would be minus 2.179. So you'll be, if the value lies in between these two range, then you'll accept the alternate hypothesis, accept the null hypothesis. I'm sorry. So that is t-test. And to wrap up, I'll just explain you what is hypothesis testing and a little bit of J-test and t-test, and just give you a glance. So hypothesis testing is nothing but estimating parameters of the population based on sample. Okay, so that's a very strong statement. Just try to understand it. And there are two terms. One is null hypothesis and alternate hypothesis. Null hypothesis is nothing but whatever you have it in your plate, and alternate hypothesis is nothing but whatever new statement that you want to prove. Okay, so the game is nothing but to whether to accept the new guy or like to strict with the older guy. Okay. So that's where, like, whenever you are dealing with the averages, you'll be having two tests, J-test and t-test. And J-test, whenever the population standard deviation is given and the sample size is greater than 30, then you'll be considering this. And only two things that you need to consider. So one is like, what is the Z value? What is the Z value? You, in the same, based on the confidence interval, you'll be checking the Z table and calculating the Z value. And with the new guy, and you'll be calculating the Z value of the new guy and see if he lies in between these two ranges or based on one tail or two tail. That's what I was trying to say. If not, t-test. If the sample size is very way lesser than 30, less than 30, and population standard deviation is not given. So that's where t-test comes into picture. So that's much about the hypothesis testing. Please let me know your feedback. Thank you.